Well, welcome back to video number 3, where we're going to add the rest of our operations into our cycle time estimate and create the complete cycle time estimate. So we had operation number 1, which is our rough turning, and now we're going to go back and do operation number 2, which is going to be our finish turning. So I'm going to select operation number 2. I'm going to copy the last, which is going to bring in my machine and my material. I'm going to drop down for my finish turning. I'll drop down for one of my 10 subcategories. I'm going to select finish turn, the 2 OD diameters. No need for handling time because it's already in the chuck. The length of cut. We're going to go back to cut length calculator. We're going to load the previous operation, which is rough turn. And you can see that all our information comes back in. And I'm going to select finishing and do a calculate button. And now we've got the length of cut for the tool to be able to do the finishing operation. Again, copy it to the clipboard, back to the form. Average tool and work diameter is 3 inches, and then calculate. So now the software goes through, calculates the RPM and the feed rate and the time to be able to finish that operation. And again, creating the cycle time estimate is just going through the part operation by operation. The next thing we're going to do is operation number 3, and we're going to rough groove. So I'm going to copy the last. I'm going to select grooving. I'm going to select a grooving operation, which is one of the things I have in my subcategories. I'm going to rough groove, and then I'm going to come back looking for my length of cut. So again, back into CLC. I'm going to look for turning operations and OD grooving. I'm going to do rough grooving here. So the OD of the rough stock is going to be 2.750. The diameter of the groove at the bottom is going to be 1 inch. The width of the groove is 1/2 inch. The width of the grooving tool is 125. The amount of overlap is 20 thousandths. And then we're going to leave 10 thousandths on the walls and 10 thousandths on the diameter. I'm going to save this operation again as rough groove so that when I come back and do the finish grooving, I won't have to input the numbers again. Hit the calculate button, come up with our length of cut, copy it, back to the form. Average tool and work diameter, so we're going from 2.75 to 1. So we're going to call this about 2.5 inches, and then calculate. So now we have our RPM, our feed rate, and our time to be able to rough groove the part. I'm going to go to operation number 4. Copy the last, select OD grooving, select my grooving operation. I'm going to finish groove. I'm going to go get to CLC again. I'm going to load the operation that I have, which is rough groove. I'm going to say I'm going to finish groove the operation and then calculate. So 2.13. And then we have a calculate again. So this is our time to finish groove the part. If I can take a look at any time as I build the estimate into what's happening with the part, and I can see that I have all my operations in here. Up to date, we've got 4.32 minutes to be able to do the part. And I can reorder these operations or copy the operations or delete any of the operations through this view operation screen. But the important thing is I can get the time that's being built for the manufacturing of the part. Last operation. We're going to go through and do operation number 5, but now we're going to switch the machines. We're going to go and we're going to put it into a Haas V of 1. We've still got our 6061 aluminum, and now we're going to do some drilling. So I'm going to do some spot drilling first with the high-speed tool. I'm going to spot drill the 2 holes. The handling time and indexing time, so I'm going to put some handling time in here that's going to take me to put it in the vise. I'm going to call it 30 seconds. The length of cut, if we go back to CLC, you can see we have hole operations, and we're going to do some straight drilling. The total drill length I'm going to go down about to 175. We're going to do 2 holes, and we're going to calculate it. So 0.35. So you can either copy this to the clipboard or, kind of basically remember it and bring it in here and put 0.35. The tool diameter, we're going to call it 250 for the spot drill. We're going to calculate it. Then we're going to select operation number 6. We're going to copy the last. We're going to do some drilling with the high-speed tool. We're going to drill the 2 holes. I'll come back to CLC. And this time we're going to do some peck drilling. The total depth, that flange is about 1 inch wide, so we're going to go about 0.200. 2 holes. We're going to do 100 thousandths peck, and we're going to retract by 50 thousandths. So 3.6. Those hole diameters are 1875, and calculate. And so now we got 0.27 to be able to drill the 2 holes. Again, if we go back and we take a look at our view operations, right now we've got 5.25 between 2 machines. We're going to do some of the work in the lathe and 2 of the operations in the machining center. So we've got 5.25 as a cycle time to be able to do that part complete. When we come back in video number 4, we're going to take it a little step further and show what you can do with the data that you've calculated from the cycle time estimate.